Alright, here grade 10. So this is the angle between two planes, 15F.3. So really quickly, I'm just going to show you guys this. So in case if you have any questions, please bring it up tomorrow. So it says, a cube has side lengths of 10 centimeters. Find the angle between the plane defined by BGD and plane ABCD. Okay, so I did this for you guys. BGD. So what I would do, just like put circles on those points and then connect those points together, and then you'll find a plane, right? 3 points make a plane. Just a side note, like 2 points make a line and 3 points make a plane. So it's a thing, like it is a thing. It's an axiom actually. Axiom is just a fact for math. So, and then it says that there's also another plane, which is plane ABCD. And obviously, if 3 points make a plane, of course 4 points also make a plane, right? So they're saying, what is that angle that's between the plane defined by BGD and plane ABCD? So I did this a couple of minutes ago, and I had the mistake of doing this. This was my mistake. And as you guys know, I am not perfect. I'm not a perfect human, not a perfect math teacher. I make mistakes too. Like just now. Like right there. So this would be the side profile, right? And I would, like, immediately in my mind, I thought, okay, so that means it would be this angle right here. Okay? That's what they mean. Because they say in between those planes. But check this out. Because I know that this is a right angle, and then they also put this is 10 centimeters, that's 10 centimeters, and this would be theta, right? So that's opposite and adjacent, so that means it's tangent theta, and then 10 over 10, or 1, right? Tangent theta equals to 1, so that means theta is tangent inverse of 1, which is 45 degrees, okay? And if you check your answer, it's not 45 degrees, right? So this is why I gave you guys answers as well, so you can have this process. Like, don't be afraid to try it out first. And it's okay if you make a mistake, like you check your answer, whoops, like that's not it. That's the process of math. Like that's why so many math books have answers in the back of the book, so you can make those mistakes like right now, so you can learn from it. That's the point of why I do that. It's not just like to make your life easier, but it's also to help you to be a better mathematician. So that means that's not the angle that they're looking for, right? So if you guys look back to 15F.3, this is what they say. If you look at page 335 on the old textbook, they say the angle between two planes. Suppose two planes meet in a line. We choose a point P, so we're choosing a point P on the line where they intersect. So in this case, it would be this line here, line DB. There's a point in this line here. We can call it point P, point anything. Let's just go with the book. Point P, and draw a P in one plane so it is perpendicular to the line. We then draw BP in the other plane so that BP is perpendicular to the line, and so that APB, or the angle of these, the angle that's created from these planes, they will be less than or equal to 90 degrees. So what they're saying here is this. We're choosing a point where the pink plane over here, it creates a perpendicular angle. So this would be the angle bisector here, right? The perpendicular angle bisector in a triangle. So right in the middle to the base, that's a perpendicular bisector, right? And then because DCB is also a triangle, and they share a base here, right? So there's also a line, there's also perpendicular that goes straight to the base. Okay, so we established that, and it is useful later. So what we're trying to find, you can even spell it out loud, like, we're trying to find this. This is what I would suggest for all of you guys to do when your problem is all complicated and lots of things to look for, right? Trying to find, like, so you have an agenda, a goal here, right? So we have this triangle here. So it starts with point G, and then we have point C and point P, okay? Because this would be the pink plane, a part of that pink plane, and this would be our blue plane, right? Do you see how that's where they meet? So they're asking, what is this theta here? Okay. And then what else do we know? So I know that this is a right triangle because when you see a cube, it's not a crooked cube, right? Unless they specify it. So it's a cube. That means GC is perpendicular to that side there, ADCB. So it's perpendicular. It's straight up, right? It's on a right angle. So that's why we know it's a right angle. Okay. So what else do we know? We also know that a side of this is 10 centimeters. And now we need to find out just one of these, either the hypotenuse or the adjacent side here. Which one should I choose? Let's just choose PC then. It doesn't matter. You can find either one. So to find PC, I need to do this triangle here, CDB. And this is PC. Okay, so I know CB is 10 centimeters. I know DC is also 10 centimeters. But I need to find DB then. We're trying to find PC. What is PC? So DB is a diagonal. This is my sketch. Sorry for my ugly sketch here. So DCBA. This is 10. That is also 10. So this diagonal here is square root of 200. Excuse me. Plus 10 squared plus 10 squared, square root that, Pythagorean theorem. Square root of 200. So PB is square root of 200 divided by 2. So CP would be 10 squared minus square root of 200 over 2 squared. And square root that, right? Pythagorean theorem. 100 minus 200 over 450, so square root of 50. So that is just CP here, square root of 50. So the last thing that we need to do is that we need to find theta. And that's easy, right? Pull up your calculator. So this is what they are saying. So theta, this is opposite and adjacent. That means SOHCAHTOA, we need to use TOA. Tangent theta equals to 10 centimeters over square root of 50 centimeters. Finding theta means take tangent inverse of both sides. And you get theta equals to approximately 54.7 degrees. And there you go. So gotta be careful because the angle between two planes, remember that here's the key here. You need to choose a point P, or you can name it anything you want, on the line where the two planes meet. And that point is where those two planes meet. And then that, like, do y'all see this here? it creates a right angle, and this here is also creating a right angle, right? So when you've met those conditions, then you can find the angle between those planes. So it's not on the side, right? Because if you think about it, the angle would change, right? So you could try this out too. If you have a box and so let's say like you have that box here, the angle of this, so this is your pencil, this angle here will be so different than this angle over here, right? Do you see how like, let's see, what was PC? PC was square root of 50. Let's see what square root of 50 is exactly. Square root of 50 is 7, right? So that means the distance between PC and BC is longer, right? So that alone, that changes the angle, right? The value of the angle. So yeah, hope that helps. See you guys.